So this week, as I said, we're just going to take a look at one section, okay, 4.3. We'll split it into 2 days. Okay, one day we're going to talk about parallel lines, that's today. Tomorrow we're going to look at perpendicular. So last week we talked about, and we reviewed it in the warm-up, the name of a certain type of line. Not the y equals mx plus b, but the other one. Does anyone remember what that one was called? The formula we just did in the warm-up. What is it?
Slope.
Well, the second word is slope. But think about that equation. It has a slope in it, that's an m. And it also has a x1 and a y1, which is a point. So we did point slope. Now, let's just go through the formula one more time. Can someone, actually, do I already have it written? Yeah. Someone remind me, how does point slope start again? What's the first thing you put? Y. All right. What comes after that? Minus. And next thing you put? Y1. Okay. Next couple things. Actually, no, the next thing is just a symbol or sign. What sign do we put? Equal sign. What comes right after your equal sign? M. And then in the parentheses, we have three things. Something, a sign, and then something else. X minus x1. Okay. And I think I've got that right there. So that very top box on your guided notes where it says point slope form, just fill that in. Okay. Also make sure you fill in what the arrows are pointing to. Okay. M is slope, and then the other thing is your coordinate. So the first example we do, it's going to be just like what you did in the warm-up. We're just going to try one more. Okay, I'll give you a point, give you a slope. We'll practice writing the equation of the line. Okay, did everybody have that equation? Good? All right, let's try just like we did in the warm-up. So we're going to write example 1. Okay, it's coming up in 1 second. So we're going to look at two things today. We're going to write, or one thing probably. We're going to look at the equations of lines, and we're going to find one that's parallel to a certain line today, perpendicular to a certain line tomorrow. What does that mean, parallel? I don't know if we mentioned that word in here. If two lines are parallel, what does that mean about them?
What do they look like?
Yep.
They don't run into each other.
Yeah, they don't cross. And we'll talk a little bit more about what that means, like mathematically. If they don't cross, they have something in common. We'll do that in a couple minutes. All right, so first one, just like we did in the warm-up, just like we did it.
Yeah, so guys, notice you have the parentheses. You have to just have to write in the numbers, the 3 and the 5 inside your parentheses. Then you have to write the equation of the line. And for this one, guys, we'll go through step by step.
All right, so first thing, you're going to plug everything into that formula that we've gone over. The y minus y1 equals m times x minus x1.
Guys, just like we did when we did point slope before our last academic week, we'll go through step by step. Okay, y, what's y? Minus, how do you get y1? We'll go through each thing and what you have to plug in for.
All right, so the first one is the y. Do we change that in point slope form? Does that end up
We're
changing?
plugging a number into that.
What do you think? No? No? I hear no. Any other thoughts on that? Anyone think we change y? About Nicole? Look back to the warm-up. Did we ever change the y? No. The y just stays as y. So you don't have to plug anything in for the y. Every answer that you write is always going to have y as the very first thing in point slope. How about the minus? Do we change the minus? Usually? No, it just stays the same. Now, when could the minus change? Like, it could be a plus. We didn't have any with a plus, but how could that happen? Yep?
If the y1 was negative.
Exactly. If the y1 was negative, that would cause something like this. Y minus minus 2. So if your coordinate had a negative 2 in it, what's minus a minus turn into? A positive. Okay, so it could happen.
Mr. Hager, can you, just in that blank space right there, can you write what we have so far in the formula? So up until that point, going step by step, you just have y and then your minus. Because the minus is part of the formula, you have to put it.
Now, how about y1? Do we have to plug in anything for that? What do you think, Nate? Yeah, that's what we're going to get from our coordinate. So for y1, we're going to plug in the number that's the second number in the coordinate. So for y1, that's the second number in the coordinate. Okay, and how about the equal sign? Do we change that at all? Or do we cross it out? And Matt, what do you think? Do we do anything to the equal sign? No. So up to the equal sign, we're basically going to have this. That's your entire left-hand side.
Can you go back to that example on the top? So because we actually have a y1 for this one.
All right, so yeah, we'll fill it in as we go. Y1 is the number 5. So let me fill that in. I'm persistent. Y minus y1. Now, are we done? Is that the whole equation? No, we still got to do the right-hand side. That's all the x's. So the y's are on the left, the x's are on the right. What else is going to be on the right, too? Besides just the x's? The slope. Okay, we got to put the slope there. So m, that's your slope. Now, this is where we're going to get into explaining how we do it if it's parallel. And then this direction is going to change a little bit tomorrow for perpendicular. But this step right here is the only step that changes between today and tomorrow. All right? So parallel. Donovan, what did you say about parallel lines?
They don't intersect.
They don't intersect. So they'd be like this. If you compared two lines that go like this and measured the slopes, how would the slopes compare? Yeah?
They'd be the same.
They'd be the same. That's the whole key. Parallel lines have the same slope.
Yeah, for that, if we count it, you go up the same amount of lines and right the same amount of lines.
So if the question is asking you to find parallel lines, which all the questions will today, look at the number that's attached to x. Okay? We're going to use the same slope as the line they gave us. So if I say, here's a line, I want you to find something parallel to it. That means whatever the slope is of the line I gave you, that's the slope you're going to use too. And that makes them exactly the same steepness.
You guys make sure like these notes, especially today, in terms of like writing out notes for tomorrow, the really only, like Mr. Hager said, the only real new thing is going to be that perpendicular piece, right? If it asks you to write a line that has a perpendicular, it's not going to be, the slope won't be the same, it's going to be something different.
So you don't have to worry about if asking for perpendicular. We'll get to that tomorrow. You don't have to write that.
So in terms of writing down notes tomorrow, really the only thing we're going to fill in, when it says 1 and 2 for perpendicular, we're going to fill it in tomorrow and we'll do some examples. So in terms of writing notes, it's not going to be, in terms of writing down actual steps, the only steps tomorrow will be filling in those 2 blanks, and the rest will just be examples.
Okay, so let me write down what I've got so far. Okay, that's from the previous step. And now what comes right after the equal sign? What do we always put there? M. let's go back up and look at what m is. M is the number attached to x. What number is attached to x here?
2/3.
Negative 2/3.
I didn't have
And the reason we don't change that number is because they asked for what kind of line? Parallel or perpendicular?
to.
What kind?
Perpendicular.
No.
In a parallel.
Parallel, right? It says write an equation of the line that's parallel. When they ask for parallel, you don't change the slope. Because slope, you want them the same. If they're not the same, they won't, if they're different slopes, they're going to end up crossing, okay? So what's my slope? What did we just say? Someone said it. Negative 2/3. All right, am I done now? Not quite, I still need my x's. So the next thing is my parenthesis, which I'll just move this right next to it. So now I have an open parenthesis. And what's the first thing that's going to go inside the parenthesis? X. Does it change? No, that x never changes. All right, so I'm going to write down again what we have up to this point. So we've got y minus 5 equals negative 2/3. We've got our parenthesis. We've got our x. And what comes right after the x? Usually. Something before the x1. Minus. When could that minus become a plus? It's usually a minus, but what would cause it to become a plus?
If the other x is negative.
Exactly.
The x1, if the x coordinate you were given was negative.
So if that was a negative, yep, then we'd have to fix it. And now x1, that's what Chris was just talking about. That's what we get from our other coordinate. Okay, it's the first number in the coordinate you were given. So in a second, we'll scroll back up and look at the coordinate we were given. Oops. All right, so I'm just going to copy down what we have again. I'm sure a lot of you could probably do most of this in one step because you did it all in the warm-up. Just kind of going through it. We're just breaking it down because we haven't done this in a while. So I've got my y, my minus, my y1. I've got my equals. I got my m. I got my parenthesis. I got my x. I got my minus. Very last thing I'm going to put is what?
4.
4. Let me go back up. Let me see what x1 is. I don't agree with the 4. The 4 is something else, but we're actually, whatever this number is right here, you never even need that number.
Would it be 3 then?
Yeah, it would be this number.
All right.
It's the first number
In the parentheses.
from the coordinate that's given, yeah, in the parentheses. So what was it? 3. And then the last thing is make sure you close parenthesis. That's a final answer.
Oh, it's a final.
Yep. All right, so now part 2, what they might ask us to do sometime is just to take that and make it slope-intercept. What's this one again? The one that I circled. That's called what? 2 words. Point slope. This is point slope. Now, slope-intercept. Does anyone remember what that one looks like?
Why is it so much?
That's y equals mx plus b, which we're going to write right next to point slope form where you have that bullet, first bullet. Donovan just said it. The whole key with point slope form is y is on the left, everything else is on the right.
So that would be slope-intercept.
Oh, right here?
Yeah.
Should that say slope-intercept?
I was thinking maybe to write this so they could see, like take your point slope form and write it there. Take the actual the answer we had
Oh, the actual answer?
Yeah, then we can show them how we change it.
Okay. So that's our point slope form. Now we got to get y by itself, so we're going to do two things. Usually you have to move a number to the other side, and you have to do distributive property. And that's pretty much the only two things you ever have to do. You always do distributive first. So when I distribute this negative 2/3, is that going to affect anything on the left? At y minus 5. What do you think? Nigella, what do you think? Distributing the negative 2/3, does that affect the y minus 5? No?
Distributing?
Yeah.
Oh, yes.
Yes?
Well, so if we distribute on the right, where the parentheses are, if I distribute over there, is it going to change anything on the left?
No.
Sure.
Yeah.
I need a confident soul right now. I need somebody who's really confident.
What?
Are you confident, Chris?
I think so.
All right. I like the tone. It sounds confident.
That's not false.
Now, if I do this, and I distribute out that negative 2/3, does it change the y minus 5?
No.
No. Good. I like it. So that y minus 5, for now, it's just going to stay exactly the same. So let's copy that down. But we need to distribute. All right? So we might need a calculator if we've got fractions. We'll say negative 2/3 times x. How do we write negative 2/3 times x? Just negative 2/3 x, yeah. That's all you can do. All right, so we've got negative 2/3 x. Now the next part, negative 2/3 times negative 3. Well, let's just start with it's a negative times a negative. What's a negative times a negative?
Positive.
Yeah, it's going to be a positive. And now let's just do it on the calculator. Negative 2/3 times negative 3. Negative 2/3 times negative 3 is positive 2. So positive, we already got the positive. Put a 2. Are we good? Is that in y equals mx plus b now? No, it's kind of in the middle. It's not point slope anymore. It's not slope-intercept. It's like halfway between the two. What do you think the last thing we need to do is? Point slope always has what by itself? Y. So the last thing we got to do,
Add 5.
we got to get rid of that negative 5. Now, whether or not you add or subtract, that's going to depend on the problem. You always do the opposite operation. Sorry, Mr. Wright, are you looking for a pencil?
Yes.
Yeah.
Allow me.
All right, if you see a y minus 5, you're going to have to add. If you saw like y plus a number, you would subtract. But you either add or subtract at this step. And just make sure you do it on both sides. Oops. So let's do what Donovan just said. What did he say to do to get the y by itself? What do we do on both sides? Add 5. So let's just going to kind of squeeze it in there. Squeeze it in right there. Negative 5 plus 5. Well, Bethany, what happens when I do negative 5 plus 5? It cancels out. I won't cross it out too much because I still want you to be able to read it. So it's y. Now there's nothing else. Negative 2/3 x, that doesn't change. Right? When you do plus 5, that doesn't do anything to the negative 2/3 x. But the plus 2 is going to change. What's plus 2 and plus 5 give you? Plus 7. And there's a line that's parallel to the line you were given, and they won't cross. I'm going to graph them on the calculator so you can see it. Okay? But look at the slope of this line, negative 2/3 x. Look at the slope of the line we started with, negative 2/3. Same slope. Whenever they're the same, they're going to be parallel. Okay, let me draw them real quick so you can see them. I'm going to graph negative 2/3 x plus 4. Okay, this part, I just want you guys to watch this. So, negative 2/3 x plus 4. That's the line that they gave us. Now, this is the line that they said to find. Negative 2/3 x plus 7. Negative 2/3 x plus 7. When I hit graph, the calculator is automatically going to draw both of those lines. The original one is going to be in blue. The one we just found is going to be in red. Now, if they're parallel, we're going to hope that the lines don't what? We're going to hope they never touch, right? They don't cross. That's the first one. And there's your second one. Does it look like those lines ever cross?
No.
No. And that's because they're parallel. You don't have to graph them and show that. I just wanted to show you what parallel looks like. Okay? Looks like that. All right, so same kind of problem.
Just say we want to have these. We want to have them try to at least plug it in. At least set it up. They don't have to solve it, but at least plug it in. Only
Yeah.
4 examples.
Yeah.
Yeah, 2 examples. So guys, for this one, take a minute and just, you don't have to solve it, just set it up. Just plug it into slope, point slope form. You don't have to distribute or do anything like that. All I want you to do is take what's there and just set it up in point slope.
Right, so you're finding an equation of a line that passes through this point. So if you were to draw it, the line has to go through the point that I circled, and it has to be parallel to the one I just underlined. So it's like they're giving you 2 conditions. It's got to go through this point, and it's got to be parallel to this other line. So we'll try that in another 30 seconds. Okay, so let's take a look. So we're going to use point slope form. Can someone remind me, first thing you always write down in point slope form, doesn't matter what the numbers in the problem are. What is it? Yep, always start with y. Donovan, what always comes right after the y? Well, there's no y2 in this problem. There is a y1, but there's something that comes before that. That's going to be the next thing.
Oh, a negative sign.
Negative
But
sign.
in this case, it's a positive sign.
Yep, we'll talk about that. So we got a negative sign. And now what number comes right after the negative sign? y1, which is negative 4. I know I can do something with that. I'll come right back to it in a minute. Brady, what comes after the negative 4? It's going to separate the left and the right-hand sides of my equation.
The y.
Nope, we already did the y's. Equals. Yeah, someone said it. Yeah, but it is equals. All right. Next thing I'd put after the equals is m, and that changes depending on the problem. Now, if they want a line that's parallel, we always use the exact same slope as the one they gave us. If it's perpendicular, we got to do something different. But parallel, use the same slope. What's the slope of the line they gave me? Negative 4. All right, so that's m. Next thing that comes after m, Alex? Parenthesis. Next thing that comes after my parenthesis. Yep, go ahead. x. Next thing that comes after the x.
Minus.
Minus. And I know we might have to fix it. We'll hold off. What comes after the minus? -5. Your x value. Now, we kind of need to fix that a little bit. We just need to fix two things. Instead of y minus -4, what can you put?
Y minus 4.
Y plus.
Y plus 4. And instead of x minus -5,
X plus 5.
there you go, x plus 5. Now, what format is that? What type of equation? That's point slope. Now the directions here, they weren't specific. They just said write an equation. They didn't say point slope, they didn't say y equals mx plus b. So if that's all the directions said, then I would say you're good. Let's practice changing it to point slope, slope-intercept, just in case they,
Like we did last time.
yeah, just like we did last time. So that's point slope, that's a perfectly acceptable answer.
If it says write that equation of a line, you want to change it, correct?
The directions were not specific, so.
Okay.
Nope. If that's all the directions said, I would accept that as an answer, because that is the equation.
Okay.
But now let's try it in slope-intercept. Okay? What's the goal in slope-intercept? You're trying to get what letter by itself? Y. Two things you have to do to get y alone. First thing is to do what? Distribute. What number am I distributing here?
-4.
Exactly. For now, as Confident Chris told us last time, that left-hand side stays exactly the same. Like that little alliteration there. It's too early for that. Y plus 4 equals, what's -4 times x? You can't do anything with that. What's -4 times 5?
20.
-20.
Why would it -20?
Because it's negative times positive.
But that's bigger than 4.
When you multiply negative times positive, it's always negative.
Okay.
You're thinking of like adding.
I'm not here today.
Now, this equation you have right here, it's nothing. It's like in the middle. It's not slope-intercept, it's not point slope, it's halfway between the two. Last thing I have to do to get y by itself. How about Joe?
The last thing? You have to subtract 4.
Subtract 4. Subtract 4. That's gone. What's going to be on the right-hand side?
-24.
Before that.
-4x.
Yep, -4x. And then what did you just say?
-24.
-24. And that answer is also correct. Both of those boxes are correct. The top one is point slope. The bottom one is slope-intercept. On the test, it'll probably be a mixture. There might be some where we say write it in point slope, and there might be some where we say write in slope-intercept. Point slope is
We'll
easier.
specify, I guess.
Yeah, point slope is quicker because then you don't have to do the last two steps. Slope-intercept takes a little extra time. All right, so now when we talk about parallel lines, we said that they have to have the same slope, right? All right, so here's a line, and here is another line, which I'll just make a different color. Are they parallel?
Yes.
Yeah. Are they parallel now?
Yeah.
Yeah. How about now?
No.
No. But I didn't change the slope. It's still the same slope.
But they're the same line.
Yeah, the same line. So,
The same exact line, yes.
so when you have the same exact line, even though the slopes are the same, they're not parallel. That's kind of a little special case. When they're the same slope, but they're the same line, they're not parallel. And that's what we're going to mention right here. So remember, lines or equations of lines that have slopes that are the same are what? If they're the same slope, that makes them,
Linear.
No?
Well-
Parallel.
parallel, but they can't be the same line. So lines are equations that have slopes that are the same, and the y-intercepts would have to be what?
Different.
Exactly, different. That's what I was just getting at in that picture I just showed you. All right? If you say to me, I've got two lines with the same slope, are they parallel? I'd say, I need to know a little bit more. Are they the same slope and are they right on top of each other? Or are they the same slope and different y-intercepts? If the y-intercepts are different, I'd say, okay, we're good, they're parallel. But if they're the same slope and same intercept, they're the same line. Okay? Right on top of each other.
Oh, you didn't give it away, sorry.
Yeah, I already kind of said it. So same slope, different y-intercept. That's the part people usually miss.
Parallel.
They're parallel.
All right, so guys, we looked at,
Oh, yeah, the coach is taking.
we had you guys do the, we gave you a point, then we gave you the slope, plug in the point slope, figure out what your equation is. All right? Like Mr. Hager said, we might have you keep it in point slope, might have you put it in slope-intercept. All right?
Right.
So now we're going to give you the coordinates of 3 lines. All right, so I'll give you guys a little bit of time. 'Cause on your notes, in the parentheses is blank. So you just have to fill in these numbers. All right? Like I said, as you guys are writing that in, like think about what we had to do first is we just gave you a point, we gave you the slope, and we said come up with a line, figure out a line that's going to be parallel to that, but also go through those 2 points. Like Mr. Hager said, we could ask you to give us, equations and parallel lines, but again, that's why we give you that point, so we can be more specific. All right? So for this, we're giving you 2 points. All right? In order to figure out if a line is going to be parallel to another line or not, yeah, we could draw it out, that's fine. Right? But what are we looking at specifically? We're looking at the what?
2 things.
What are those, not so much for this, but what are those 2 things we have to look at? What's gonna be the same and what's gonna be different? We just talked about this. What will be the same? In the equation of a line, what's gonna be the same? Matt? The slope will be the same, right? And what's gonna be different? Matt?
2 lines.
Right. The slope will be the same. The y-intercept will be different. Good, Savannah. All right. So that's what we're looking at. But now it's only giving me these 2 sets of coordinates to figure out whether they're parallel or not. So what should I be looking at specifically in these? What am I going to look at? What do I have to figure out? The what of those lines? Again, what's going to tell me if they're parallel or not? I have to look at the what. What's the thing that's the same that tells us that they're parallel or not? It's the what of the line. The slope, right? We're looking. So again, here I don't have the slope. The slope's not given to me.
And what else is given to you that you still need to find? You've got to find the slope and the y-intercept. Because if you find 2 lines there and you say, oh, the same slope, what if they're the same line? So you still got to find the y-intercept too.
Mm-hmm. So for these, what do we have to do first? Because before, like examples 1 and 2, we were given the slope. For this, we're not given the slope. So what do I have to do? There's this specific formula I have to use to figure out the slope. Not y equals mx plus b, not y minus y1 equals mx minus x1. What does it use? Rise over run, right? But what's that particular? Because with these, they're not graphed. So I can't just look at it and like, okay, I'm going to count. The line goes up to the right. I can count up. I can count up and then go over. I can't do that. There's a specific formula I have to use. And Yusuf says rise over run, and he's not wrong. He's on the right track, but we need more than that. What was that formula we used to define slope only?
Y1 minus Y2 over X1.
Perfect, right? So Yusuf is right. Why? He said rise over run. Remember, your y-axis is up and down. That's your rise. And like Gigi said, that's why it's y1 minus y2. Your run goes across, right? Your x goes across, all right? So what Mr. Hager's doing, guys, is what he did was he just took all 3 lines and did it one by one. So it gives you a little bit more space.
I'll finish.
All right. So again, like Gigi said, y1 minus y2 over x1 minus x2. You can do it the other way around as long as you're consistent. So when I say that, I say you can do it the other way around as long as you're consistent. What do I mean by that?
You could do it Y2 minus Y1 over X2.
Exactly. Like Gigi said, you could do y2 minus y1, x2 minus x1. You can't do this. You don't have to write this. Don't do this. Because I have my second x coordinate first down here. You got to be consistent. I think for some people it might make more sense to put the first coordinate first because they don't have to go back and forth. It's up to you how you want to do it, as long as you're consistent. All right. So I got to figure out my slope first. All right. So in these coordinates, right? What would I label that -1? What would I label that as? Somebody tell me. Gigi? X1. So if we're calling this X1, we better call this Y1. All right? Ryan, what am I going to label these two? What's the -3 going to be? If this was X1, what's this going to be? X2. These are my second coordinates. And then this is going to be Y2. You could do it the other way around too. You could do these as X1, Y1. This is X2, Y2. It doesn't matter. But you can't do X1, Y2. It doesn't work that way. So just going to be careful about how you label them. All right? Here's the top part of my formula to figure out slope. Slope only. What's going to go on the top? Based on what Gigi told me about how we can find slope. What's going to go on the top, Nathan? I got everything labeled, right? And it's going to plug it in now. What's going to go on the top?
3 -2.
3. Remember, minus is part of my formula. Just because this is y2 is negative, it doesn't take the place of the negative that's there. You have to put the minus, then do this. What happens? When I have this, what happens? I have 2 negatives in a row. Yeah, this changes to a positive. I'll put it above so you can see it. All right, so I did the top. On the bottom, what am I going to put? What do you think, Miguel, on the bottom? So I did y1 minus y2 on the top. Now I got x1 minus x2. What numbers are going to go in there? So I got my x. I'm doing it just like this: x1 minus x2. I'm going to plug in those numbers now. -1. Yep. Minus is part of the formula.
-3.
Yeah. -3. What happens? Turns into a positive. Now I just do the math. On the top, someone raise their hand. Tell me what you get.
5.
5. Good. Ellie, good. On the bottom, what do I get? Paige, what do I get on the bottom? So I got -1 plus 3. 2. So there's my slope, 5 over 2. All right?
So now, if we're trying to find lines that are parallel, we're going to hope that those other lines we look at have a slope of what?
Right?
What is it? 5 over
5
2.
over 2.
They have to have the same slope, but what has to be different? for them to be parallel. The y-intercept. What I would do first is I would find the slopes of all those lines. If you find two that have the same slope, then they could be parallel. Then you have to take the extra step and find the y-intercept. I would not find the y-intercept of that line yet, because that's going to take a lot longer. That's going to be doing what we just did in the previous two problems. So I would find the slopes first,
Yeah.
and any slope that's different, you can eliminate it.
Yeah, so
you don't
we-
even have to worry about it.
So when we're doing these guys, when we're given the two coordinates, like Mr. Hager said, find the slope first. If you have a slope that's different, that one's just eliminated. Then we'll have to go through to make sure that they have different y-intercepts. Okay? So next one. Let's do. Oops, I don't want to do that.
You trying to move that down?
Yeah, I was gonna move it down. That's the formula. There we go. All right. So now this one. We'll label this. Oops. X1, Y1, X2, Y2. Matt, here's my formula to find slope, right? What am I going to write? What numbers am I going to write on the top?
So for y1, you're going to put 2
Yep.
minus -2.
Perfect. What happens?
That becomes a
There's
positive.
a pause. I'm just going to write it above so you guys can see it. All right? Laura, what about the bottom? So we labeled everything. That's what we should, this is what we want to write on the bottom, right? What are the numbers going to be that we write on the bottom?
1 minus -1.
1.
Now, before Mr. Roy even
Minus.
finishes, he can keep going. I already kind of know something before he even wrote the bottom. Anyone kind of see what I already noticed?
What'd you notice?
What do you think I noticed? I'm trying to see if this line's going to have the same slope as the one above it.
Oh, yeah, yeah.
It can't, right? I already know the top on his fraction is going to be 4. Top in my other fraction is 5. It's probably not going to be the same slope. So if you notice something like that, you can save a little.
So with this on the top we're going to get, say x1 minus 1, okay, make that a plus. We're going to get 4 over 2. That simplifies to what?
Should have put 1 half.
This means that line means division, right? So 4 divided by 2, which is what? 2. This simplifies to 2. Or I could say 2 can go into both. On the top, I'll get 2 over 1, which is 2. Remember, anytime we're dealing with fractions, it means division. All right? So we got different so far. So for this, we could get 5 over 2. We could get 2. We may not any one of these 3 lines may not be parallel. All right? We don't know. So let's see what we got. We already got our formula.
But what do you know about A and B? You know that those are what? You're guaranteed.
Are those lines going to look like this?
That they're parallel?
You think they're parallel?
Well, they might be. Well, I don't know.
You definitely have enough
Why,
information.
guys, why can't these 2 lines be parallel? Someone raise their hand and tell me. We just figured out the slope of those 2 lines. Why can't they be parallel, Nicole?
They don't have the same shape.
Yeah, we're doing this. When I do this and do the whole y1 minus y2, x1 minus x2, when I do that, that gives me my slope. If the slope isn't the same, those lines aren't parallel. All right? We don't have, like Mr. Hager said, we don't have to take that next step to see if they have different y-intercepts because their slopes are different. So they can't be parallel. It's not possible. All right? Last one. I'm not going to label this time. All right? Let's just assume this is my first set of x coordinates. This is my first set of coordinates. This is my second set of coordinates. All right? Based on that, to figure out my slope, what's going to be on the top? Ellie?
2 minus -2.
2 minus -2.
And on the bottom, it's
The
going
bottom?
to be 4 minus 2.
4 minus 2. I agree.
Since they're both negative, would they?
This will
would that
become
be
what?
Positive.
I'll become a positive. Yes.
And then it'd be 4 over 2, which then equals 2.
Okay.
So that would equal the one up there.
So now we got some possibilities, right? So if I looked at all 3, right? I know you can't see it up there, but the slope of my first line was 5 over 2. So out of the three, which one cannot be parallel? Which one cannot? A, B, or C? A, right? Because it's 5 over 2. Mr. Hager, this circled in red all the slopes we figured out so far. This one cannot be. Not parallel. That cannot be parallel. All right? We have a possibility with B and C. We figured out the slope, but what do we need to do now? We said the slopes have to be the same, but to have lines that are parallel.
Y-intercepts have to be different.
Y-intercepts have to be different. So like Mr. Hager said at the beginning of this, now we have to go through and do what we were doing for examples 1 and 2. We'll put it in point slope, and then we'll put, after we put it in the point slope, we'll put it in the slope-intercept. All right? Remember, point slope is this. Y minus y1 equals mx minus x1. So when we ask you guys to do this, this is when you go through your list. All those notes we took at the beginning. You're just looking, okay, y is, if we look at it, it tells you. Then put your minus. How do I get y1? How do I get my m? How do I get my x? How do I get my x1? If you go through that list, it's going to tell you step by step how to get each thing that goes in the formula. All right? So I'm going to take, I get my slope now. Again, we'll use this. We'll use 1, 2 as our coordinate. You can to figure out the coordinate, you can use either one. You can use the first one and the second one. I chose the first one because there's no negatives. All right? I don't have to deal with negatives that way. All right? So I'm going to write it in point slope, right? What am I going to start with? What's the first thing I need to write? Matt?
Y.
Y. After the y comes what, Matt?
Negative.
Minus. Based on this coordinate, somebody besides Matt tell me, what's my y1 going to be? What's my y1 going to be? What number am I plugging in for y1? Who said it? 2, 3. I agree, right? I'm looking at this. I already have it labeled. There's my y1. After that comes what? Someone tell me by raising their hand. After that comes what? Equal sign, good use of? After that comes what? I'm here. What's after that? M, which is, we just figured out, is going to be what? M stands for slope. What's my slope, Gigi? 2. That's what I just figured out. Parenthesis. How about x? Garrett, how about x? Do I plug a number in for x?
You do x minus 1, right?
X, right? I agree. I'm going to leave x minus. We're going to scroll back up. I can. And then my x1 from the formula, like Garrett said, is going to be 1. But again, that tells me nothing. That tells me nothing about the y-intercept. I have to get it. That's in point slope. I got to get it in slope-intercept. To get it in slope-intercept, what's the first thing I have to do? 2 steps. Distribute, right? Nothing happens on the left. We've talked about that. When I distribute, what do I get on the right-hand side? When I distribute, what do I get on the right-hand side? When I distribute here, what do I get? 2x. What else? So I did 2 times x gave me 2x. 2 times -1 gives me -2. One more step, right? Y has to be by itself. What do I have to do to get y by itself, Magelli? Add 2. Now, on the right-hand side, do I add the 2 to the 2x or to the -2? Why can't I add it to the 2x? What doesn't it have? Right? It would, this positive 2x and this positive 2 would need an x. It doesn't, right? I can only add it to things that it's like on the other side. Doesn't have an x, so I can't do that. I'm going to add it to the 2. I'm going to get y equals 2x. This just cancels out. -2, if I owe someone $2, I pay him $2, there's nothing left. I don't owe him anything else. All right? So Mr. Hager went ahead and did the other one. He went through, he plugged it in the point slope, and then he changed it into slope-intercept. All right? Do we have, again, what are we looking for? We're talking about parallel lines. What has to be the same? What has to be the same? The slope, thank you, Chris. Slope has to be the same. All right? In this equation of a line, what's my slope? In this equation of a line, what's my slope? Everybody tell me. 2, right? Remember the number with x. Down here, what's my slope? 2. Same, right? What has to be different? The y-intercept, right? I got a y-intercept of 0. I got a y-intercept of 6. Yes. So lines B and C would be parallel because their slopes are the same and their y-intercepts are different. So again, to do that, you have to go through, figure out your slopes first. Do the y1 minus y2 over x1 minus x2. Do that first. If you have numbers that are the same, then you can figure out the y-intercept to see if they're going to be different. All right? So B and C would be parallel, like we just talked about. Guys, for the sake of time, we'll skip example 4.
Oh, good looks.
Thanks, Yusuf. So now this one, so if we go through slope-intercept form, we've already talked about this a bunch today, right? Y equals mx plus b. In that formula, what letter represents slope? The M, right? Or like we've talked about, the number with x, right? M is slope. So to see, we're always focusing on the number with x attached, all right? So if a line's written in slope-intercept form, to see if it's parallel, we have to look at 2 things. We've talked about this, right? What has to be the same? What has to be the same? The slope, right? What has to be different? Y-intercept, right? So make sure it's, again, some of these may not, y may not be by itself. Make sure y is by itself, all right? Second thing is, number with x has to be the same, and y-intercept different. So like we just did there for that last example, example 3, that's quite a bit of work because you have to, the slope's not given to you. So you have to figure out the slope, and then if you have slopes that are the same, you have to put it in point slope to see if they're actually going to have different y-intercepts. What we do next is not going to be as much work. They're already going to be in slope-intercept form. You may have to rearrange a little bit to get y by itself, but you're not going to have to figure out the slope. Those ones took a little bit longer because we had to figure out the slope. It wasn't given to you. So it takes a little bit longer. So again, big thing, whenever we're looking at to see if a line's parallel, whether it's this year, next year, your junior year when you have geometry, you always want to make sure it's in slope-intercept. You always want to make sure y is by itself. Look at that number with x. If it's the same, you get a chance, as long as the y-intercept is different. All right? I'll do. All right. I know some of you guys are still writing that down. All right. So same kind of thing, but different because the slope's already given to you. Even though it doesn't say slope equals, you know that what we just based on slope-intercept form, you know what the slope is. But first thing we have to ask ourselves, let's go through and look at each line. Line A, line B, line C. Is line A in slope-intercept form? Is line A in, how many people say line A is in slope-intercept form? Raise your hand if you say it is. Nobody says it is, okay? Why is it not in slope-intercept form? Savannah? Y is not by itself. Savannah, what do we have to do to get y by itself? Add 4x. I'm going to add 4x. Now to get y by itself. Y equals, what's going to come after the equal sign? Because remember, it's y equals mx plus b. So what's going to come after my equal sign? 4x, right? I'm taking this, and again, I'm moving it to the other side to get it in the right order.
5.
Plus 5. Good, Ellie. Again, all I had to get y by itself, all I had to do was move the 4x. Remember, if you're moving an x, put it after the equal sign. If you're moving just a number like 5, -2, 7, make sure it comes after the x. So you want to make sure you keep it in the formula, right? Remember, if it's y equals mx plus b, you want to make sure the number with x comes after the equal sign. You want to make sure that your slope-intercept is the last thing written in the equation. All right? Next one, line B. Is it in slope-intercept? Yeah, y is by itself, it's fine. Last one, in slope-intercept, what do I have to move?
4.
Add 4x. When I rearrange, what's it going to look like? Y equals 4x plus, good use of? 4. Very good. What's the rule again? Same slope, different y-intercept. Looked at you. How do I know which number how do I know what the slope is? What's going to be attached to it? The x, right? In this equation, what's my slope? 4. Just a 4. In this one?
5.
In the last one?
4.
Which one's eliminating? Which one's eliminated so far? B, right? We got a chance with these guys because the slope's the same. B's gone. Same slope, different y-intercept. What's the y-intercept of line A?
5.
What's the y-intercept of line C? Are they different? Yeah. So line A and line C would be parallel because they have the same slope. Number with x is the same, and the y-intercept is different. All right? Again, you guys, we're just typing out the explanation on the test. You're not going to have to explain why. All right? You're not going to have to explain why. We're going to skip example 6. Now, guys, like I said, you'll need your notes tomorrow to fill in the stuff on perpendicular. We'll also do example, what do we skip? Example 4 and example 6. We'll do those tomorrow as a warm-up. Homework, guys, it's not super long. A couple things to keep in mind. Weird week. All right, listen, please. You have plenty of time. You have like 3 minutes before you have to leave. Tomorrow is the last day of new stuff for this quarter. All right? Last day of new stuff. All right? Take-home test this week. We talked about this the academic week you guys had before we went on break. Take-home is going to be assigned tomorrow at the end of class. It'll be due at the beginning of class on Friday. All right, if you're going to be out for some reason, you need to have a conversation with Mr. Hager and myself. If you turn it in late, we're not going to accept it. We had kids last year that got 0s for take-home. I will be after school on Thursday. I'm sure Mr. Hager will stay tomorrow as well. If you want to stay after school, I'll stay till 4 o'clock tomorrow. You can stay after and get it done. You don't have to worry about it. All right? It's going to be due at the beginning of class on Friday. Friday is going to be MCAS open response for the first half of class. Second half, we'll start the midterm reference sheet. We'll do something in terms of starting to be ready for the midterm. It might be the reference sheet, it might be a review, but something like that. There will be homework this week over shop week because we had the short week, so you guys can start getting ready for the midterm. Your midterm will be 2 weeks from today. So your next academic week, you guys take midterms. Our midterm is on the 16th, so 2 weeks from today. All right? And you guys have homework.